In the previous sections, we've been looking at different ways of writing equations with lines. And so far, we've talked about primarily two forms. The standard form, which is the one where you have some number in front of your x plus some number in front of your y equaling some other number. In order for this form to be standard, all the a, b, and c are integers. So they're not fractions, they're not decimals. And more specifically, a is always positive. Excuse me. The other one that we've looked at a lot is slope-intercept form. The y equals mx plus b equation. So there's one more form of the equation that can be really helpful as we're going through this section, and that's the one that's called the point-slope form of a line. The point-slope form of a line is y minus y1 equals m times x minus x1. Now these two forms are the forms that we would use to give our final answer in. But this one can be a useful form if the information we're given doesn't let us go immediately to one of those forms. So let's talk about the different ways we'll write that we can get to the equation of a line. A really helpful resource for you is the table that's located on page 244 in your book. They give a summary there in a little blue box of all of the different starting and ending places. So if you're given a slope and a y-intercept, which path do you take in order to get to your equation? And given a point and a slope, and given 2 points, and given if they are horizontal or vertical lines, how can you tell? So we're going to summarize those here as well. If you're given the slope of your line and you're given the y-intercept, the most natural fit for that would be the slope-intercept form. So you're going to use y equals mx plus b, inserting your slope here and the y part of the coordinate, or the x part, I'm sorry, the x value of your y-intercept coordinate here in place of b. And then you can use algebra to rearrange it into standard form if that's what the problem asks for. If you're given just a point and it's not the y-intercept, it's some other point on your line, and you're given a slope, that's where this new form is going to come in handy. You're going to use the y minus y1 equals m times x minus x1, where you're going to put the point that they give you in here. Here's the x and the y values. The slope is going there. And then you'll rearrange it, rearrange, not a very mathy word, but it'll work, rearrange into slope-intercept or standard form as directed. So depending on what the directions ask the final form to be. You can put in a point and a slope there and rearrange it. If they give you 2 points, we're actually going to have to take several steps to do this. You're going to start by finding the slope, and if you remember, the way we do that is that slope equals the change in y, so y2 minus y1, over the change in x, x2 minus x1. Then use either one of the 2 points, and this one is a tricky step. It's a place where I see most folks make their mistake if they're going to make one. That you were given 2 points, you can pick either one of them, it doesn't matter which one, and use the y minus y1 equals m times x minus x1 form. The point goes in there, your newly found slope goes in here, and then rearrange to slope intercept or standard, again depending on what the directions ask for. And then our final point to be reminded about are those special case kind of lines, horizontal lines and vertical lines. That a horizontal line with the point AB, its equation is always y equals whatever that b value is. Vertical lines are similar. In a vertical line, with the point AB, a vertical line that passes through the point AB, its equation is always going to be x equals whatever the a value is from that equation. So now that you have your toolbox assembled of all of the different starting places and how to get from there to the answer, in the next video we'll try a few examples.